Chytrid fungi degrade diverse organic matter, including low-nutrient substrates that are not favored by most other saprotrophic fungi. By adding these different baits to water samples in petri dishes, chytrids can be found colonizing the baits and subsequently be isolated in pure culture for study. Common chytrid baits include onion skin, cellophane, shrimp chitin, snake skin, spruce pollen, and baby hair. Onion skin is boiled and dried. Use the thinnest pieces. Cellophane can be purchased from a craft store or at Fisher Scientific. Shrimp chitin is acquired by shelling cooked shrimp and treating the exoskeleton with hydrochloric acid, potassium hydroxide, and ethanol. Snake skin is boiled like onion skin. Spruce pollen is collected by knocking pollen from trees into bags. More information on baiting for chytrids can be found at Dr. Longcore's main chytrid laboratory website, linked to in the description. To begin, place water samples in petri dishes. Dr. Simmons flame sterilizes forceps to prevent contamination between samples. He adds a few pieces of onion skin, about 1 to 2 square millimeters in size. Other baits, except for pollen, can be added in a similar manner. The pollen is sprinkled directly into the sample. Note that you can add multiple baits to the same sample. However, snakeskin should be added alone since it attracts lots of oomycetes. Seal the petri dishes with parafilm. Check the pollen for chytrids as soon as 3 days and up to 1.5 weeks after inoculation. Other baits can be checked after a week, but might take a month to show growth. Chytrids found growing on baits can be isolated and brought into pure culture. Colonized pollen grains can be washed onto a plate or isolated individually. For larger pieces of bait, dragging the bait through solid media is a good technique. Finally, active zoospores can be isolated for culturing. We'll start with isolating chytrids growing on pollen. To inspect the pollen for chytrid growth, Dr. Simmons touches a cover slip to the surface of the sample where there is a clump of pollen. The cover slip is then placed onto a glass slide for viewing under the microscope. Here is an image of a colonized pollen grain like what you might find. To culture these chytrids colonizing the pollen, Dr. Simmons takes a pea plate with antibiotics, which is denoted by the plus sign, removes the cover slip, and washes the contents of the cover slip onto the plate. He repeats this for the slide. This medium, P, is the default chytrid culturing medium used by many mycologists who study chytrids. The recipe for P medium and other media useful for chytrid culturing can be found at the University of Michigan's Cesium website and are linked to in the video description. After the pollen has been added to the plate, inspect the plate and draw circles around colonized grains on the bottom of the plate to monitor colony formation and eventually transfer them to fresh media. Individual colonized pollen grains can also be isolated and placed directly onto a plate. Methods for doing this are discussed in the second video of this series, isolating single cells and establishing dual cultures. Next, we will talk about the dragging method to isolate chytrids growing on pieces of bait like onion skin, cellophane, or shrimp chitin. Michelle places the bait directly on a slide and looks for chytrids under a stereoscope or inverted microscope. Make sure the bait doesn't dry out while you are looking under the microscope. After you've found some chytrids, cut off that piece of the bait. Using flame-sterilized forceps, pick up the piece of colonized bait and drag it through a petri dish. It's important to do this under the microscope so you do not lose track of the bait. After you've dragged the bait through the agar a number of times, place the piece of bait on a clean plate. The goal of this technique is to clean the colonized bait of contaminants that are not attached to the bait. Although there is likely to be lots of contamination on the drag plate, both the drag plate and the plate with the piece of bait should be kept since they could both show chytrid growth. The final method is the Zoe Spore Release isolation method. With this method, colonized bait is placed in a drop of sterile water on a petri dish and allowed to release spores. Here, Eva is using an already established chytrid culture for demonstration purposes, but the method is the same. Eva transfers the chytrid to the drop of water and leaves it at room temperature. After a few minutes, the Zoosporangia may start releasing zoospores. At first, the zoospores may be lethargic and not moving around much, but will eventually swim away. At this point, you can use a mouth pipette to suck up the zoospores. These microscopic videos show the zoospores being sucked up by a pipette. Finally, transfer the zoospores to a petri dish. Roll the drop of liquid around to spread the zoospores across the plate. In summary, we talked about using baits to isolate chytrids from environmental samples. Pollen can be washed directly onto a plate. Other baits can be dragged through media. Any Zoosporangia can be isolated and allowed to release zoospores, which can be sucked up and plated. After isolating chytrids from baits, use standard microbiology aseptic technique to establish pure cultures.